Well, so why are you taking time? You will typically get 1,000 feet done a day, and we are slowing you down. Can we agree? Why are you doing this for us?
There's about 6 people in this whole state that give a shit if you know what you're doing.
They can't touch you anymore.
That is the truth. Jonathan being one of them. And I've become the second, or another one. You're not going to learn this in the next 2 days. But you're going to learn a hell of a lot in the next 2 days. Get you well started. A lot more than anybody else has ever learned. I'm going to give you a story. This is why I'm involved. We do a lot of systems in different cities that we can't get to all. So I hire no help on that. Well, I had 5 of them I needed in another county than this. Man went through the classes, been doing it 2 or 3 years, figured he knew what he was doing. He done 5 for me, and 4 of them got turned down. And it wasn't good stuff, either. It was simple stuff that you'd have thought anybody would have used, right? So, this is the first time ever in this industry that a class has been put on to get somebody started right. Get them going, you know, to let them know the ins and outs and what not to do and what to do and to look for. So,
Ronnie,
I'm glad y'all came to Jonathan.
This class used to be taught with pictures in a classroom, right? And that's not acceptable. You don't have a chance to succeed. The mistakes that were made by the other installer were things that honestly, like, we're going to give you a foundation, but you desperately need to go work with somebody for a few days before you go do this. You need some opportunity to go work with people, take it, and there are a lot of people that need help right now. They'll take you for a few days if you're willing to work. Do it. Ronnie, I appreciate you being willing to give back to the industry. It's important that we as an industry hold a high standard, because for a long time maybe we haven't. We got by with things, but that won't take us very far.
Well, the other thing is you don't want to be that guy. What did Jonathan say? When you screw that up, it's screwed up. You better hope there's a good area for repair. And that ain't where you want to be a week into a brand new house in your repair.
When they designed these, Ronnie, did they give any extra soil to account for screw ups? No. There's not an inch of extra dirt out here to account for a screw up.
This lot here is twice as big as what we normally see. This is a great area. Most of our lots is half this size. And we're putting panel in. So pay good attention and thank Jonathan for doing it, because you may not even know you're screwing up. You didn't even know. Hell, you didn't. What kind of training you got? You know? So this is good stuff. I mean, it ain't rocket science, but it is something that's important, and it's
gotta have common sense.
You gotta have a lot of common sense.
You do it. You're gonna have to know the rules. They're gonna have to. You got a lot to learn. We're gonna get you there. We're trying to get out early and come touch this stuff, see it. So when we go talk about it on a picture in the office, we actually have something to point to in our memory to say, all right, that's what he's talking about. That's why it matters. All right, all right.
And the little things, I mean, the smallest things make the most difference in this. You know, just like him step down, you saying, I'll be doing one here in a minute. That's very important. Very important. I mean, that ditch holding the water it's supposed to hold no water, or holding half the water. And it all ends up down on that last line, blowing out of the ground. So, you know, there's stuff here you definitely need to pay attention to. It takes a lot of time. This ditch I dug, not all of them you can dig, but you know, you want to get them good and level like that, but I mean, if it's doing this a little bit, that probably ain't going to be a big problem. But that's step down here.
What'd you put them fittings in for over there, those 16? We got 2 of them over there. Kick up.
I hadn't showed him yet. You talking about on the hump overs, on the connections? We hadn't showed him yet. Can you show him what we do here next?
Yeah. What you don't want
slow to flow down.
I want to make sure I fill up this trench.
They say you can go sloping like this. Just come out of one end cap and go right in the end cap. Well, if you've got a big slope to it,
Right, it goes straight to the bottom.
you've got a small piece of dirt holding all that water back in that trench up there.
So you're slowing it down.
We want that water to just damn stop. The slower it runs, the more it absorbs.
Right.
So you want that ditch to fill up over here, and I want my ditches actually to fill up a little extra and then go over. I want that line to take all the water it can absolutely take. But me and Jonathan, we're on different ends. We're coming together over the years. But we started out, he was an inspector. I was an installer. We enemies, man. You don't know what the hell you talking about. But I go to systems, and I've been to systems that you come out here and you've got water coming out down on that last line. You come up here and just probe into that chamber there, and that thing's half full. What happened? That damn step down wasn't right.
Because it's so far.
We got to get our dams at the right elevation to
Yeah.
control. If we don't control the flow of water, if we let water control itself, we are doomed in these things, because water's going to do what's easy. What's easy? Run to the bottom of the hill,
Least
right?
resistance.
And we got to slow it down. We got to make it soak in where we want to. So we're just exercising control. I'll walk them back over there and show the dams.
And maybe Jonathan's probably talked about it, may talk about it some more. But what's very important is your elevation. If you'll notice on that first system up there, them first two ditches I didn't use them 16. Right? But you want to pay attention to that elevation coming out of that tank. You want to know where it's at. You want to know where it's at when you get to the end of that solid line in that first chamber. You want to make sure there's at least 2 inches of fall. Depends on the length of your pipe. But it's got to get out of that tank. Don't ever back water into that tank.
And we talked about the importance of making sure we didn't have settling in that alley tee, because backing water up in the tank was catastrophic. We can't get so focused on the drain field and that's slowing water down that we accidentally back it up in the tank, because then we're shooting ourselves in the foot. We'll walk back over there and look at that.
And I usually on my first ditch, when I go to my second ditch, I will do the typical out of that end cap right into the next on the slope. And I used to not do that. But I've learned that, all right, I'm gonna give up. It's still gonna work like it's supposed to, but I'm not gonna back no extra water up in it, because I do not want to back water in that tank.
And these are
That's the
slab
first, that's the
houses.
first one.
Yeah.
There's just not a whole lot of
that's too
cushion.
close.
Yeah, after you get out of this ditch and you start, dropping elevation, then you can start backing water.
Right.
Because there's no way that ditch 6 inches lower than that ditch is going to back up in it and back it up into that tank.
Yeah.
So I just don't want no water going the wrong way. But I do want it to stop, and I want it to work slow.
That's why we don't put fall on ditches, right?
That's right.
Our goal is level as it possibly can be, slow as we possibly can make it through this ditch network, because we're going to get maximum absorption. These soils are not going to move water like Manio dune sands, right?
No.
They're going to take some time to soak it in there, but it will work if we do it right.
And I'll tell you something nobody talks about. There used to be an old guy that wrote articles in the Pumper magazine. He was the repairman or something. I forget what they called him. But people talked about these systems like here, where you're flooding one line to go to the next line to go to the next line. A lot of inspectors and engineers thought that was terrible. They ought to be on manifolds. We ought to have some kind of distribution better than that. But you know what that septic tank's for, though? It's to hold solids back, detention time for the solids to sort of separate and settle out, and clear water come up here to these drain fields. That chamber's doing the same thing.
Yeah, I think about this first chamber in this series
Yeah.
is a long settling chamber.
Yeah.
If any fats, oils, grease, or solids make it here, that's 100-foot long line to settle out. So what kind of water quality does line 2, 3, 4, 5 get?
Better.
Man,
be better all the way down.
better. And so really that's why, Ronnie, when we look at life expectancy of systems, why cereal lasts just as long as parallel, because while we may flood this one and really challenge this line, we put a higher quality effluent. The distribution box just sends everybody an equal chunk of what they got. So you're gonna have to go both ways. South Carolina, you'll be parallel with a D box. North Carolina, you'll be cereal. So we'll do that here too. We're gonna get out of your way.
I told you we was coming together.
All right, slowly.
Appreciate it.
We still do this.
Thank you, sir.
Let's walk right over there. Just